Welcome, everybody, to the 8th BristolR meeting, the second fully remote meeting, given current global lockdown and all that good fun stuff. Nobody's moving around Bristol very much, so we're still remote for the time being. We'll obviously keep you posted as things develop with where we will be in the future, but certainly remote for now. What have we got? Thanks to our sponsors, of course. So our sponsors are Unai, which is where Nick works. They have, what have they supplied? They've supplied historically beer and pizza, but this time round it's Zoom, right?
Yeah, Zoom and getting to work on things for this in work time.
Which is always nice. We like that. And also the R Consortium. Our consortium is a industry group of people who kind of support the R language, and they have kindly provided us with meetup fees and a small grant for the next year, I think. Thanks to Nick for sorting that out as well. We want you to speak at BristolR if you haven't already, and even if you have, we want you to speak again, because we can never get enough of people speaking, and it's always the hardest part about organising any event. So if you would like to speak at BristolR, let us know. We're here to help. Nick and I have spoken, despite appearances to the contrary, at many places around the world, and would be happy to give you help or advice or guidance on a talk or whatever, or you can just do a talk yourself without telling us, but we need to know to schedule you in, so that part would be useful at the very least. There's a link there where you can go and send us some details, or you can get in touch with Nick or myself via meetup. I thought it would be useful, given that I almost completely missed IRAM, which was last week, I think, just to briefly mention a few upcoming events in the R calendar. All of the events that I'm about to mention have gone virtual, so they're online rather than cancelling the event. Some of them have been rescheduled and things to accommodate the switch to virtual and stuff like that, but all of the events are virtual. Some of them are free, some of them are paid, but we'll just whiz through some of them really quickly. So USAR is on the 7th of July, URL there, everybody knows what USAR is. The BioC 2020 is the Bioconductor annual conference, and that's on the 27th of July. There's a URL for that on the screen as well. What else have we got? We've got JSM. JSM's going virtual this year. That will be on the 2nd of August, 2nd to the 6th of August. Again, URL on the screen. Lander Analytics in New York run a thing which they call R Conference, which is good. That's virtual this year as well. So that one's in August. The R and Medicine folks, they are a kind of smaller group of R Consortium people and interested parties who work with R in medicine specifically, are having a virtual mini conference thing again towards the end of August. I'm kind of hopeful that the R and Pharma folks will do the same. The YR team in Poland, I think they've moved this back by a couple of months, if I remember rightly, but towards the end of September now, the YR team in Poland will be having their conference. Have we got any more? We don't. So next up, we have our actual talks rather than just me waffling on. So first up, we have Fodil from Algeria, I believe, which is awesome. Thanks for joining us. And we also have Colin from jumpingrivers.com, consultancy for R and data science and that kind of thing here in the UK. And Fodil, if you would like to go first, I have to stop sharing my screen.
Sure.
And
I will just share my screen just quickly. Can you see my screen?
We can.
Thank you. So thank you very much for having me, and thank you for the invitation. I will have the honor to present my package called scrollrevealR. Basically, it allows you to animate shiny elements when they scroll into view in a web browser. So it's on Cran since yesterday, I think. You can download it from Cran or from GitHub. And what it does, it activates the scroll revealer JavaScript library. So under the hood, you can, for example, visit the scroll revealer website and just to get an idea of what is possible to do. So I'm not a big fan of slides, so I've decided to go through a live demo on RStudio. So I thought I have opened a session. That's okay. I will open another one. There we go. Perfect. So is the Zoom okay?
Yep, looks good.
Great, thank you. So what I did is I have created a basic Shiny app, a very basic one, in order just to show you how things work with Scroll Revealer. So I have created two plot outputs, one table output, and an image. So if I run it, just to have a look at the application. So I have the distribution of HWY variable from the MPG dataset. What's really important, I think everyone knows the MPG data frame. It's part of the, I think, dplyr package, or I think ggplot package. It's a data frame which is built inside the ggplot package. Quite cool data frame. So here a plot of the distribution histogram of the CTY variable. Here a table. Yeah, and just below an image of the RStudio icon. So in order to animate these shiny elements when you scroll into your web browser, it's extremely easy. So what you do is you just need two functions. For example, let's say I want to animate the first plot. I have given it an ID of PLT1. So what I do is I use the scroll reveal function. So the scroll reveal function takes many arguments, but the most important one is the target. So which shiny element I want to animate. So here I have to match the ID, and I have to add an hashtag before the name of the ID. So I would say hashtag PLT1. And now it's not enough, because I have to activate the JavaScript library which is run behind the hood. So I will have to use another function called useReveal, just at the end of the UI. So if I run that, you can see that my plot, I don't know if I can show you, if you can see. I will try to scroll down and up just to in order to give you a look. So it's a bit quick, but you can see that it's animated when you scroll into view. I will make it more apparent by tuning another argument called duration. So it's in milliseconds. So by default, it's I think 1000 milliseconds. But let's say I will give it 5 seconds. So 5000 milliseconds. So if I run it, you will see that it will take longer. So it will take a bit longer to animate. So each time I scroll into this element, it will like fade in into your application. Not something extraordinary, but maybe useful for some applications to make them look a little bit fancier, I would say. So you can see here. Now, what if I want to, for example, animate my two plots and my table? I would have just to wrap my element and inside a vector. So I would say BLT1, so hashtag BLT1, BLT2, and table 1. So these are the IDs of my Shiny outputs. So if I run that, it's a bit slow, sorry. So if I run it, all my elements are animating. So you can see that if I scroll, my elements appear and disappear automatically. Now we can play a little bit and change the behavior of the animation. For example, if you remark it, you can see that my elements, for example, here the plot goes from the bottom to the up, to the top of the Shiny app. So I can change this behavior using an argument called origin. I can choose from top, bottom, right, or left. So if I use origin, I would say, for example, give me my element from the top to the bottom, move it from the top to the bottom. I will have to right top. Now, if I run my Shiny app, it will goes from the top, as you can see. So quite simple, nothing really extraordinary or fancy, but maybe useful. Now, what if I want to make, for example, a delay? Let's say I want my elements to wait for some time before triggering in appearance. I will just use the delay argument, quite simple. By default, it's set to 100 milliseconds, but you can just give it another value, like, for example, 1 second. So it will the application will wait 1 second before triggering the element. So let's run it, and you can see that it's take longer, right here also. So all my elements are like fading in a longer way. So there is a warning that I want to give here in this presentation. It's vis-a-vis of the tables. So here in the tables, there is a problem. If you scroll down in order to look at the bottom of the rows, for example, at the last rows, the table may disappear, like here. Because the application considers the table as the first part of the area. So when you scroll down a little bit, it will disappear. So it's quite annoying. So what you can do here is using an argument called reset. So here, reset, if you use reset, so it's a Boolean argument. It takes true by default, but when you put false, the Shiny element will will animate only once, and then it will become static. All right. So it will animate only once. So if I scroll down here to my table, you can see that it is animating here. But let's say I want to go back. Now it's fixed. It won't disappear. All right. So same for the image. you can of course use this kind of function and taking all the elements at what time and wrap the elements inside the vector, but I don't really encourage it. Instead, I think it will be better to use a function for each element in order to tune the duration, the origin, etc. For each element. So let's say I want to use it on the image. Here, the image it is written inside a tag, the tag image. So I will have to write it without the hashtag. Of course, some knowledge of HTML is good, but it's not really required. So if I use that, my image will scroll. So here it's faded out because let's just open it. I can't see everything in. Let's open it in the browser. I think it's way better. Yep. That's why it is. I think I need to add some spaces at the bottom. Because the image reached the bottom of the web page, so it is disappearing. So let's add, I think, some more BR tags. Let's add some space here, a lot of it. And here we go. Now if I run it, where is my RStudio icon? I don't know why it's disappearing. Let's see if I have just made an error. I think I should wait. I don't know, maybe it was working. I don't know why. It's here. So it's faded. I think it's related to the table. But anyway, what I want to show you is that you can, for example, modify the degree in animation for each element. So, for example, if you, let's say I will just wrap everything here. Let's remove that. So if you run the application, you will see that the elements move in like limited way. So if you want to modify this behavior, you can just use another argument called distance, I think, which defaults to, let's say, which default to 20 pixels. So by default, it's 20 pixels. So the elements, when they animate, move in 20 pixel distance. So if you want more abrasive or more flashy animation, you can just add some spaces, some distance. For example, let's say 200 pixels. So if I use, if I decide to implement 200 pixel, I run it. Let's open it in the browser. I think it will. Yeah, let's open it in the browser. So you can see that my plots are moving from a larger distance. So they are coming from, it's like they're coming from more, I don't know if it's, sorry for my English, but it seems like they're coming from longer distance. That's the feeling. So here also, so you will have to wait a little bit longer. So that's, I mean, the main components of the function. So it's really simple to use, and I think really straightforward. You just have to play a little bit with with the animation. Of course, if you find that an animation is not working properly, or just don't animate it and animate the more important ones. I think I have presented, I think, everything. So it's quite straightforward to use, I hope. And if you have any question, or please don't hesitate. I think I'm done.
Thanks,
It
Fodil.
was too short, I think. No.
You know, there are no rules. There are no rules.
Thank you
very much for that. Does any well, actually, before I ask if anybody else has any questions, I have a question of my own.
Yeah.
Said it was the scrollrevealR JavaScript library. Could you tell us how you've managed to turn that into an R package?
Yeah, actually, it's quite easy. So Shiny is built upon HTML, CSS, and JavaScript. So in Shiny, you can run some JavaScript code. For example, you can just use a function called tags. You can use the tags function, and inside the tags, you can run script. And here, inside an HTML function, you provide your JavaScript code just as a character object. So you provide your JavaScript code, and it will run normally. So what I did is I have taken the code of the JavaScript library. I have put it inside a function within this function, and each time the user call it, it will run the code inside this function, so the JavaScript code. So when you use the scrollrevealR function, you're using a JavaScript function.
Cool.
Yeah.
Okay. That's awesome.
Yes, and here the useReveal function is used to trigger the JavaScript library, because there are many ways to incorporate JavaScript library inside a package. Many people use HTML widgets.
Mm-hmm.
That's really a cool process. But in this situation, it was quite simple to do so. It's not really a huge package. It's a very targeted package. So what I did is I used what's called the CDN. So in JavaScript, you can activate a library using a link, which is provided by the user. So when you run useReveal, you are running CDN behind.
Okay, cool.
Yeah.
Does anybody else have any other questions? Let me just check the chat. Nope, not this time. Okay, cool. If anything, you know, if you think of anything, feel free to drop it in the chat. Hopefully Fodil will see it. But thank you very much for that, Fodil. We can't really do a round of applause, can we? But
thank you very much. Thank you for having me. That's nice.
Brilliant. Could you stop sharing your screen, and
Sure.
we'll hand over to Colin.
Mark, while you're doing that, the chat is disabled. I don't know if that is a host thing.
Thanks, Doug.
That is entirely my fault. I do apologise.
Do you know how to fix it, Nick?
If you click on the big security button, and it should have chat enabled or chat disabled as an option.
Oh, look at that. This big security button, I don't think I've ever clicked on that before today. It's very exciting.
Mm-hmm.
Okay, the chat is enabled again, so hopefully it works for everybody now. If you have any questions or anything like that, drop them in the chat, or wait till the end. And with that, we'll stop watching Nick eating and move on to Colin. You're muted, Colin. I don't know if that's intentional.
Great. So, quick double check before we get going. I'm just going to play a clip that's got nothing at all to do with today's talk whatsoever, but it's much more fun than trying to... Can you hear that? I've no idea if that's a naughty multi-python, so I'm not going to play it all. Right. Thank you all. Well, thank you for Nick and Mark for inviting me along today. Thank you for joining me. And today's talk is part talk that I did last year at USR. So if you were at last year's USR, or you were really bored and watched the YouTube video, then you've just seen the first half, and then the last part is some new stuff that I've put together. So, who am I? So my name's Colin Gillespie. So I'm based up at Newcastle University and work part-time at the university and also part-time at Jumping Rivers. So I'm one of the co-founders of Jumping Rivers, and we do lots of sort of cool R and Python and all that sort of stuff. Essentially Mango, but with a cooler name, just for the Mango people in the audience. So, as you can see, I'm somewhat tongue-in-cheek throughout this entire video. So I'm going to pick in one or two people whose cameras are on. So you might want to turn your camera off if you don't want picked on. But it's all complete tongue-in-cheek. So I've written a few R packages over the years. One in statistics. R Typeform is for sort of APIs and sort of messing about with questionnaires, and benchmarking is for sort of checking your CPU. So let's jump straight into it. Oh, sorry, another slide of plugging. Forgot about this plugging slide. Jumping Rivers, founded 4 years ago. Nick D's the National Innovation Centre for Data. So we are moving in June, but due to reasons that you're probably aware of, i.e. we're not moving office anytime soon. We'll be moving there in the next few months, and with our studio partners. Right, so the whole point of this talk is to think a bit about R and security and data science in general, right? You know, so we're all messing about with data, I suspect. You know, some might be looking at really private data, but I suspect whatever data we have, we probably would get a slap in the wrist if it sort of somehow leaked its way onto the internet, right? You know, there's very few of us that can just sort of mess about with data in that way. And my argument is ours is secure, but the problem is us and me, right? So whenever I say us, I do mean myself as well as you lot. So this is my favorite clip, and I've watched this so many times and I still laugh at it.
Talking about cybersecurity today and how safe people's passwords are. What is one of your online passwords currently?
It is my dog's name and the year I graduated from high school.
Oh, what kind of dog do you have?
I have a Chihuahua Papillon.
And what's its name?
Jameson.
Jameson. And where'd you go to school?
I went to school back in Greensburg, Pennsylvania.
What school?
Hempfield Area Senior High School.
Oh, when did you graduate?
In 2009.
Oh, great.
It's like my cat's name and then just like a random number.
Okay.
But,
Have you had this cat for a while?
yeah, she's my childhood pet.
Aw. And what's her name?
Her name is Jolie.
Jolie. So like a password of yours would be Jolie and then a number.
Yeah.
Like number 1?
Like my birthday,
Oh, when is your birthday?
June 12th,
Oh, nice. And what year were you born?
95.
Oh, great. So Jolie 6 12
Nine.
95.
Yes.
Got it.
So you mean to give my password right now? No, I cannot do that.
But we all want to know what it is so we can tell you if it's strong or not.
Oh my goodness. Let me think. Okay, one is Tel Aviv. Yeah. 468, and then Israel. It's only 3, but it's, you know, it's for me it's strong enough.
Ireland 1 2 3 4. Gemma 1 2 3. Spelled Gemma.
Well, most of
So Nick's already seen this, and it's still funny. I think my favourite is the last person, which Gemma with a G. You know, just to make sure you really get the correct, you know, spelling of the password. So I gave a similar talk to this at the Royal Statistical Society a few months ago, and the person before me was a professor in pure maths, and I followed nothing at all in her talk. You know, it's just over my head. You know, really hard maths, making sure things are secure, making sure people could exchange secrets. And then I was after her, and you know, this video came up of what's your password, and people just give them the password. You know, all the security is blown out of the water. So I did some research. Right, so you know the sort of research I'm talking about, and I know you're thinking of Wikipedia, but it's not Wikipedia, it's Google. Let's go old school. So if we go into Google and type in hacker, and then we look at the images, we can see what a hacker is, right? You know, so a hacker is clearly someone who wears a hoodie while sitting at the computer in the dark, right? You know, this is the core criteria of being a hacker. Why would you sit in the dark? Because it'll just give you sore eyes. And why would you wear a hoodie? Oh, so we do have one amongst us with the perfect backdrop as well. Typically, they have green writing as well. All right, so if anybody's got green text, you know, they're clearly one of this top secret organisation. And now that you've seen this, you know, the next time you see a story about hackers in the newspaper, these pictures will appear. You know, it's not just the Daily Mail. Things like the BBC and the Guardian also use these sort of completely bonkers pictures. You know, this is a hacker. I did steal this idea from a guy called Troy Hunt, to be completely upfront. So they use green text, and hackers are really scary, right? This is the sole purpose. You know, you could tell these people are scary. Look at this person who's got his arms up against glass, staring out at the world, about to kill everyone. And then we come to this, right? So this fine, upstanding individual is Ryan Clark, and he's a hacker, and he hacked the CIA, right? So let that sink in. You know, this guy here hacked the CIA, and he's wearing a red jumper and a pair of tracksuit bottoms, and his mum had to take him to court, right? You know, so you've got scary people with hoodies looking at green text, and then you've got the person who hacked the CIA with his mum because he had to take his mum to court. And those two things just seem so far removed. You know, it's just, how can this be true? And so I've got a very modest security goal, right? So my modest security goal in life is I only want to get hacked by adults, right? So anyone who hacks and steals my stuff should be at least able to buy a drink in a pub, right? You know, that's what I want. They should be at least able to buy some Stella from the off license, right? If they can get some Stella, then I'm still going to be upset, let's face it, but at least there's something there. And then you think, well, okay, what about this person here? So what do you see here? So normally I'll get people to shout out, but for those of you who can't shout out, which is everyone, then the thing to note is this little white post-it note. And if you had really good Zoom, what you'll be able to see is you'll be able to see that the former Minister of Greek Intelligence has got username minister and password 12345. So there's two things going on here. One, why you're getting your picture taken, and two, why do you have to write down that password, right? You know, why do you have to write down 12345? Of all the passwords to write down, this shouldn't be one of them, right? And I'm sure no one has passwords going about on the desk with little bits of paper. You know, I'm sure we'd never do that whatsoever, or have a book of passwords under a desk. Yes. So let's think about RStudio. So RStudio, you might have come across them as a sort of small startup, I think based somewhere in the US. They've got a not bad IDE that it's worth trying out if you've not come across RStudio. And we use lots of RStudio stuff, right? So we run lots of RStudio in the cloud. So when people come to us for training, we fire up RStudio in the cloud, okay? So we'd send out usernames and passwords, and we've got it just sitting in a server, and that gets rid of all that sort of pain and suffering from installing stuff. And so it's really easy to set up. You know, you can create an account, your cloud account, so Azure, AWS, DigitalOcean, whatever you want. You can Google. If you've never done this before, you could probably do it in about 10 minutes, right? So I wrote a blog post on how to do it a few years ago. So even if you're not really familiar with this stuff, you could probably get it up and running in 10 minutes just by pointing and clicking, right? So it's quite easy. There's a single click to install. So in AWS, that's an Amazon thing. There's a little, someone has provided a sort of container where you just need to press a button and it's all magically there. You don't need to worry about anything. It's just there. It's great. Someone's also made a Docker container. So if you're not familiar with Docker, people lie about Docker all the time and say it's really easy. Took me days to figure out what enough Docker was and how to run it. But there's even a Docker container, you can point and click and launch it. And the default username and password for this Docker container and for the Amazon was username RStudio, password RStudio. So this was from about a year and a half ago now, okay, 2 years ago. So it's now changed. And in the documentation, the authors, so one was Dirk, I can't pronounce his surname, and the other was a guy from Durham, Louis Aslett. They had the default password RStudio, and they said very clearly, don't be stupid, make sure you change your username and password, right? You know, if you're going to do it, change it. So what could we do? Well, if we were bored, we would try and think, well, can we find any instances of RStudio kicking about? So we can go to shodan.io, right? So that's shodan.io. So this is a search engine for services, okay? So Google's a search engine for finding pictures of kittens and puppies and all sorts of things. This is a search engine for looking for things that are running PHP or Apache or Nginx or that sort of thing. So what we can do is we just type in RStudio up here, and then we'll get, thanks a little second, we'll get 2,354 results of people running RStudio, right? You know, this isn't bad in any way. You know, it's just like saying, you know, give me sites that are running WordPress, right? You know, it's not, if this is scaring anyone of I can find your site, then you're in lots of trouble, so it shouldn't. But we've now got 200,000 odd or 2,000 odd RStudio sites. We've got services, we've got organizations they're running on, Amazon, Google Cloud, DigitalOcean, operating systems. And we've also got a nice little link. So if I click on that link here, I get a nice username and password. Right? And if you're going to guess a random username and password, what random username and password would you possibly guess? I am not going to type it in just in case it worked, but I did type it in 18 months ago, and the very first link worked. You know, first time, username RStudio, password RStudio, and it was in someone's RStudio server. And it wasn't a sort of dummy messing about with Google, it was someone's proper setup with scripts and data and stuff. And I very quickly logged out, so I don't really know any details, because I thought, oh, that's a bit scary, yeah, I shouldn't be here. So that's, you know, it's now changed, you know, so if you go to this stuff now, it now forces you to choose a password. But to me, that was really scary. You know, with this page here, you can imagine writing a little R script, grabbing all these IP addresses, all 2,000, having a little script that just tries RStudio/RStudio, and then just cycling through and seeing which ones it works for. Right? And that's, to me, not really hacking. You know, I think of hacking as sort of MI6 and, you know, CIA and doing really clever things, not writing a for loop to grep for IP addresses, right? You know, but yet that worked. So that's a bit scary. Something else I did a few months ago was I looked at Bioconductor. So Bioconductor is in our repository for genomics data, right? So it's not the sort of place you go when you're bored, right? You know, it's people with microarray data, RNA-seq, Affymetrix, all these sorts of stuff that you'd only use if you're a pharma company, if you were involved in a university, a government, you know, so someone with real data. Patient data contains over 1,000 packages. And the way you installed Bioconductor was you'd run this script. So what source does is it downloads this R file, okay, and then runs this R file on your computer, right? And you could go to this URL and you could have a little look at this R file, or if you're really paranoid, you could do wget and download it, or you could do other things. But you download this file and run it. When you run this command, this is the equivalent of opening up your laptop, giving the person who wrote this script full access to your laptop with you logged on, and then you going out to McDonald's if it was open and you could walk in, right? You know, that's how much trust you're placing. When you run this source command on a web resource, you are saying, I have complete trust in this person who wrote this R script, and I'm going to go away from my laptop and they can do whatever they want as my user, right? So whatever you can do as your user could be grab all your SSH keys, install stuff, install keyloggers under your username. You can do all sorts of funny things, right? You're giving them complete access as your account, right? Well, I couldn't also hack Bioconductor. That's far beyond me, even though I have watched CSI multiple times. But what I can do is I can buy things, right? So I do have a credit card. And so I bought some purchases. So I bought bioconductor.org, and then I bought buyconductor.org, and then I bought bio, I have no idea how to pronounce that, so I'm just going to stop. And then I bought that one, and then I bought 13 of these domains in total. Okay, so I just went through and dropped off one letter at a time from Bioconductor. And that cost me less than £100. Cost me £200 to renew them. Don't go for, I won't say the name, I might get sued for that one. But yeah, so don't go for people whose parents are your web domain. And this is a domain hits I got, right? So basically people can't spell, people can't type particularly well. And this was what the domains hit I got in the first sort of 3 or 4 months of running this experiment. So these are unique IP addresses to my fake domain, or not fake domains, to my domains. So someone has tried to download an R script from my domains and run that R script on their computer, right? And these are unique IP addresses. And it's averaging around about 7 to 8 per day. Right? So it's 7 to 8 computers I could get per day that I could completely own. Right? I could have complete access to that user account. Right? And I think, well, what sort of accounts would be doing that? Well, I basically got all of the top 10 unis. So I had people from Harvard, Stanford, MIT, Yale, Oxford, Cambridge, I had the whole lot. By now I've had all of the Russell Group universities in the UK. I've had Zurich, I've had all the unis, right? Anyone who does sort of this stuff I've had. I've had all the governments, right? You know, so all the government departments in the UK that you might think would be using this stuff have been hitting my servers. All the other governments in the world you might think would be doing this, got them. All the pharma companies, got all them too. Right? And that's really scary, right? You know, all these people would have had really sensitive data and they really wouldn't want anything bad to happen. And the best possible outcome for these companies would be if I was just a bit of a script kiddie and just deleted everything, right? That's the best possible outcome. The worst possible outcome could be I look at your actual data and then increase some of the numbers in one of your spreadsheets. So your control, your treatment drug, which wasn't actually effective, I just bumped on a few percentage points to make it look like it was effective. And now all of a sudden you're going to be spending hundreds of millions of pounds running an experiment that no longer works. Right? All with minimal effort. Right? And that's really quite scary. You know, so even though, again, this has now been changed. So I did this about a year ago, I suppose 18 months ago. Bioconductor have now changed the way they install, so this is now no longer the way this installs. As I said, I've had to renew this because I'm still getting lots and lots of hits. And you can imagine what's happened is this install method is kicking about in a bit of paper that gets passed around wet labs of, oh, there's someone new coming in, here's how to install Bioconductor, run this bit of paper. Right? So even though it's now a whole new way of installing Bioconductor, I'm still getting significant hits every single day. So I feel it's only right to, since I did this silly experiment, I need to keep paying for these URLs. As an aside, I didn't do anything illegal here, so there's nothing illegal. All I've done is purchase domains and look at Apache logs, right? So I didn't return anything back from this R script, you know, I didn't look at anything, you know, so there's nothing other than looking at Apache logs. Right, what else can we do? So we can go to our bloggers. It's much more interesting when we actually just go to the site. Our bloggers. Right, so what can we do in our bloggers? Oh, it's a great icon there. Well, we can go down and we can see all the wonderful people that do blogs. Where's the contributing blogs? Full list of our bloggers. All right. So we can get the blog list. There's quite a lot of blogs here. These are all the people that have contributed to our bloggers over the last however long. So there's about 750 odd. So what could you do with this site? Well, I'm going to guess that if you were really bored, you could scan this list of blogs. You know, so you can imagine writing a little bit of HTTR to grab this web page, to download all these URLs, and now you've got a list of 750 URLs, if you're bored, I'm guessing. And then you might just scan them all, ping them using HTTR and see which blog returns 404. So 404 just means website not found, it's no longer there. And I'm going to guess you'll find about 50 of them if you were to do this, hypothetically. And then you could even purchase some of these domains for around about £7 a year, I'm guessing you could do. And then you could create a quick blog post and graphics, have a nice little R package. So remember, when you run an R package or install an R package, you're installing code, and that code runs. So you could, for example, just sneak a little source command into that R package. You couldn't do that in CRAN, because CRAN would come down and destroy you, but you could just stick it in GitHub and that still works. And then you think, would anyone actually run arbitrary code? And the answer to that question is clearly yes, people run arbitrary code all the time. Right? So for the cost of £7, I was able to get people to just run randomly our code from a site that was listed in our bloggers. And that's, again, quite scary. You know, there's nothing sort of sophisticated here. You know, the scary thing here is it's such a lack of sophistication, and now all of a sudden I've got people to run code. And what's, I suppose, worse is the blogs that I sort of got 404s, they typically have just sort of lapsed within the last year. So Google still loves them. So by buying this domain, you've not just bought a random domain that you need to sort of build up Google love. You've got a domain that Google loves, and then you're just sort of putting on some dodgy content, and then it just sort of gets picked up and off it goes. And that's quite scary, you know, for not a lot of effort. So what next do we do? Well, let's suppose we want to go mining. What sort of mining we do? Well, there's only one sort of mining, isn't it? There's Bitcoin mining. So this wasn't me, in case you're wondering. This happened, what, 2 years ago? And it happened to multiple sites around the world. And people found a JavaScript Bitcoin miner running. So what happens when you visit a web page, then a bit of JavaScript started in the background and basically flogged your CPU to try and get these bad people some Bitcoins, because that's what bad people do. And the sorts of bad websites we're talking about would be, you know, these evil people, the General Medical Council. So they had a little Bitcoin miner, you know, CoinHive/libs coinhive.min. At least they minified it, so that was nice, running in the background. We had, well, these may or may not be evil depending on your point of view. The Student Loans Council, they were also running it. With the NHS, they were also running this thing. And so we're, what, another 1,000 odd websites. You know, so that's quite impressive bit of hacking. And so the question is, well, how would you get a Bitcoin miner in all these sites? Right? You've got 1,000 sites. How would you get a Bitcoin miner to go into all these sites and hack them all? Right? Well, if you want to load a crypto miner in 1,000 websites, that's hard work. So you don't attack 1,000 websites, you attack one. And the key thing, or the key similarity between all these sites, was they all loaded the same bit of JavaScript. So they all loaded a bit of JavaScript that helped with, I think it was text-to-speech, right? So for accessibility reasons, you wanted to make your website really accessible. So you loaded a third-party JavaScript add-on that helped with the text-to-speech, because you don't want to keep reinventing the wheel. Unfortunately, that third-party add-on, the security wasn't great, right? And that's what happened, right? You know, so they attacked this one site, this one JavaScript library, this tiny little thing, changed some of that code, and then all of a sudden it was picked up by thousands of sites around the world, and they automatically had this massive impact. And that's quite scary as well. You know, it's like, wow. So, would this be a problem in R? So, this is just the standard R Markdown document, right? So if you went to RStudio and you did the file R Markdown, you know, the example script, you'd get this part here. And then it also just includes some leaflet. Okay, so leaflet's just a JavaScript library for doing fancy things like this. Okay, I would switch to the R screen, but I don't want to mess up sharing and jumping between browsers and RStudio. So nothing fancy, standard R Markdown template. If I press F12, so F12 gets me the, I suppose I can't remember, the console, so JavaScript console for exploring. What we can see is in this one web page, we are also loading in some stuff from tile.openstreetmap.org, right? As you'd imagine, we're loading in tiles. It's not sort of unreasonable. You know, we've got a little leaflet package, and so we're loading in stuff. We've got some stuff here. We've also got some stuff from RStudio. We're loading in MathJax. All right, so MathJax has been loaded in. There. I have no idea what this is. Oh, some more leaflet stuff as well. Little pictures as well. Right. So this sort of attack, the stuff with the JavaScript and Bitcoin miners, well, it's exactly the same as what we could do with all the wonderful stuff we're going to have our Markdown documents or Shiny apps. You know, we're pulling in JavaScript, we're pulling in HTML, we're pulling in CSS from all over the place. You know, so one of the clients we started working with did a really nice Shiny app, you know, did some really cool things, and it pulled in over 15 different external JavaScript resources, right? 15 external JavaScript resources. And that automatically means you have complete trust in all those JavaScript resources, right? You know, you're putting a trust in. Whether you like it or not, you're saying, I trust this. And I'm then going to pass it on to my clients and say, I trust this so you can use it. So what could we do here if we were bad? Well, everyone wanting to attack, if you want to do attack in R, I've spent a bit of time thinking about this. I would find a leading person in R, right? So you can think of your favorite person, right? And then I'll tag their account, right? So we'll tag someone else's account. So you think of someone really important, someone who's got lots of cool things, and then I'll tag their account. Actually, it doesn't even have to be that super leading person. This has to be someone with the JavaScript library that people are using, right? Anyone with the JavaScript that people are using. But that's hard, right? And I'm not that good. I'm a bit lazy. So what I'm going to do is I'm just going to do some credential stuffing, right? So How I've Been Pwned is a site by Troy Hunt. So this is really good. So you can put in your email address, or in this case, I'm going to put in Nick's email address because it's much more fun than my email address. And then what is going to happen is it's going to search through sites that have been uploaded to this site of breaches, right? So if we go through this here, we have things like DataCamp. So DataCamp in 2018 were hacked, and Nick's email address, geographical location, password, IP address was listed there. Last.fm, I was also in Last.fm. I had no idea I was in Last.fm, but I was in Last.fm. LinkedIn, I suspect most people watching this video will probably have a LinkedIn account. So if you had a LinkedIn account in 2016, your email address and password was exposed. Never knew you were that old, Nick. Sort of mid-50s. So Nick also has a MySpace account. So MySpace for the children amongst us was sort of Facebook last century. It's a very old thing. No one really knows. And perhaps most embarrassingly of all is you've got sort of words with friends as well at the bottom. So we've got all of Nick's life here, including MySpace. I'm not new. And essentially credential stuffing is really easy, right? So with sort of 5 minutes Googling, you could find this breach, MySpace, or any of these other things, right? It's not that hard. And you'll end up with a big CSV file. And then you can imagine just looking for an email address, a password, and then all credential stuffing is, I try that email and password combination somewhere else. And I did email Nick beforehand, and she was aware of this site, and she sensibly uses a password manager, so all passwords are unique and all sorts of things. So that's, I didn't just jump this in Nick, because that would be really cruel. But yeah, that's how credential stuffing happens. And it's not that hard. A bit of Googling, you get a big CSV file, you get a username and password, and then you try it in github.com. And you see if it works. And again, this works really well when you don't care who you're sort of attacking, as long as you've got a big list of people that you can just sort of cycle through, right? So you don't just need to trust Nick, you need to trust every other person's library you're working with, right? And that's quite scary. And then also, there's also a bit of blackmail. So I'd like to read this tweet that came up a couple of days ago. I'll make it a bit bigger. So these were a list of sites that were hacked. I have to admit, all of these sites were new to me. Some of them I have no idea why, but each to their own. Don't Google them on a work laptop is all I'm saying. But more seriously, there was the Ashley Madsen thing a few years ago, about getting affairs. And so you can imagine finding someone's name there, and then a quick email of, I found your name in this really sort of site that you might not want your employer to know about. Can you do something for me, or I'm going to wreck my life, or wreck your life? And that's quite scary, right? It takes next to no skill. And Ashley Madsen has been uploaded here, and it's amazing. I think when the first thing that came out was all the email addresses from .gov or .ac or .edge, people using work email addresses where it's trivial to try and match people with people, right? And that's not great, not good. So we don't just need to trust developers programming, we need to trust the security practices, right? It's a lot of trust. And so typically when I've done this talk, the question I'm asked is, what about CRAN? Is CRAN secure? How secure is CRAN? Well, to get a package on CRAN would be really hard if it was, had something dodgy on it. But then you actually need to get people to use it, right? You've sort of got a two-way thing of, okay, I've got my dodgy package in CRAN. Unless it does something, no one's really going to use it. So there's a lot easier things to go for. So, you know, the last bit of the talk is sort of basic good practice, right? You know, so the basic good practice I'm thinking about is, so this is our team at Jumping Rivers. This is GitHub, and if you notice, every single person here has got two-factor authentication. So two-factor authentication just means that in order to log on to my GitHub account, you need my password, which is a random 40-character string, because it's used as a password manager, and you need some second token, you know, my phone or my key, my USB key. And so nobody's allowed to do anything with our repos unless it's got 2FA. Right? And if your organization doesn't do that, then that's, there are reasons why this isn't perfect, but everyone agrees it's better than not doing it, right? You know, it's just sort of a barrier, right? Keep on top of infrastructure, right? So the sorts of stuff that we're doing more and more is we're monitoring lots of Shiny apps and RMD files. By RMD files, I mean the HTML stuff generated, and that's sort of what we spend most of our time doing. So we spend a lot of time, you know, we've got a lot of infrastructure we now set up for clients for monitoring external resources. So the sorts of things there I'm thinking of is, well, what third-party CSS files or JavaScript files or anything else is being pulled, right? So we can now set it up in a server. So if you're on Connect or Shiny apps, we can set it up in a server, and now we just have a stream of anything external that's been pulled in by apps, and then you can whitelist or blacklist them as you need to, and that's all done by a Shiny dashboard. So we're now trying to be what's being pulled in. We're also looking at things like, is any of the JavaScript being deprecated? And this is becoming more and more of a problem. So again, the same idea of you've got a Shiny app just running, and at some point some of the JavaScript will get deprecated. You know, the browsers get updated, and you've got this app that's been running along the background because no one's ever changed it. But at some point something might break. And so again, we've got this sort of front layer of infrastructure that just sort of helps us figure out what's going on. So this is a rather synchronous HTTP request on the main thread that's deprecated, and we could dig into that a bit more. And basically, on one of the Shiny apps, we've got some fancy jQuery going on that's going to be deprecated. So we've now got about a year to fix that, and having that year is much better than it all breaking and not working. So again, we've got sort of monitoring external resources. So final couple of slides. So RStudio partners, we now spend ridiculous amounts of time installing, setting up, maintaining R in RStudio. We spend more time on setting up and security than we do in machine learning. Okay, so we started this company sort of 4 years ago. I thought we were going to do lots of cool machine learning, cool AI, but actually we're spending much more time in setup, much more time in security, much more time in infrastructure. Essentially because data scientists have little experience in web and security. So quite often when clients come on with us, we have a team of 2 or 3 people, and those 2 or 3 people are incredibly smart, while at the same time there's only so much that they can do. You know, so you can't be an expert in Docker, CSS, JavaScript, Apache, AWS, machine learning, R, Python, Git, CI, CD, and everything else. Right? It's just not possible. Right? You know, either your models are going to be naff, or your security is going to be awful, or your JavaScript is going to be slow. You know, unless you've got someone amazing, it's just not possible. And typically what we see is this part here is the one that sort of slips through because you don't know it's a problem until it's too late, right? Your bad model, we come up with a bad residual or whatever. This, you only know until it's too late. So, interested in anything I've talked about, by all means feel free to email me. And credits, lots of stuff I've got. I'll send the slides to Nick and Mark afterwards. But Troy Hunt and Scott Helm, they gave lots of sort of inspiration for this talk, listened to lots of their talks. They also do quite a nice Hack Yourself First course. Darknet Diaries is a really cool podcast on hacking things. So if you're wanting, we've all got lots of spare time now, COVID and work's just stopped. But that's a really nice podcast. Not technical, but it does give you enough technical details to figure out what's happening. So they're really nice resources. So thank you very much, and hope you found it useful.
That's awesome, Colin. Thank you very much.
Yeah, thank you, Colin.
Colin, you mentioned you've got some Shiny apps that will tell you some of this stuff.
Yep.
How do you do that?
How do we do that? So currently we're still sort of getting rid. So it's all internal, so I'm trying not to think of too much. Essentially, we're monitoring server queries, so the Shiny app knows nothing about it. So we've only got the Shiny app. We've got Shiny app to display all this stuff because it's all gobbledygook, but it's all sort of sitting completely separate from R and Shiny and RStudio and all that sort of stuff. It's sitting in sort of the Apache Nginx layer, monitoring stuff, and then feeding into a database. And yeah, so my plan is we'll soon be able to sort of demystify that error message. So just in that message there, having that is awful, but having that's better than not having it. You know, this is telling you something is about to be deprecated in the next year on this URL. And what we're planning to do is, with a little bit of figuring out what package is causing this error, we can then sort of have another column of, oh, you've got that error, it's likely to be package X. So that's where we're going. But it's sort of, and the same with this stuff here, whitelisting where possible. And yeah.
Sounds fantastic. Does anybody else have any questions for Colin? I'm seeing any questions. Okay, if we don't have any questions, this is the weird bit of the evening, right, where it just kind of ends and then we leave.
Exactly. We did try to stick around and, hey, everybody hang out and chat, and you kind of get 3 people awkwardly talking and everybody else not. So
yeah, it's kind of weird. But thanks everybody for showing up. It's been fun. Thank you in particular to our speakers, Fodil and Colin.
Thank you very much.
Yeah, thank you both. I really enjoyed both of your talks.
Thank you very much, everybody.